When we sleep, we can hardly distinguish reality from a dream. So how do we know what's real and what's not? To scientists, something is real if its properties are determined prior to being measured. An apple can be green even when no one is looking at it. But the quantum world seems to be following different rules. And 3 scientists have recently won a Nobel Prize proving our universe isn't locally real. But if our world isn't real, what is this place we live in? Imagine there are 2 people, Anna and Luke, both located on opposite sides of our solar system. 2 coins are sent from the center of the solar system, each targeted towards one observer. While the coins are moving through space, they're spinning. According to quantum mechanics, it's impossible to predict which side the coins would land on. The results are random, but when Anna measures heads, she instantly knows Luke's coin should have landed on tails. The odds of correctly predicting this even 200 times in a row are 1 in 10 to the 60, which is more than all the atoms in the solar system. Even though Anna and Luke are separated by billions of kilometers, quantum mechanics says Anna can keep predicting Luke's results based on what she got, as though the coins had a kind of telepathic connection. This thought experiment is known as the Einstein-Podolsky-Rosen paradox. It seems impossible, and yet this is how the universe works. How can something travel faster than light? What is the pixel of our reality? And how does the universe change from predictable to random? Before quantum mechanics, scientists believed that the world was deterministic. They thought that if they knew certain properties about a physical system, they could determine everything about this system in the past and the future. But then, physicists discovered a phenomenon called quantum entanglement that describes a state in which 2 particles stay connected regardless of how far apart they are. This may not sound too exciting, but imagine this works even if the entangled pair is on opposite sides of the universe. This seems odd, even in the world of quantum mechanics. We generally believe that nothing can travel faster than light, meaning there's a limit to how fast any signal can travel. However, if you create an entangled pair of particles and send them from the opposite direction, increasing the distance between them, and then measure the quantum state of one particle, the quantum state of the other particle will suddenly be determined. You can imagine it as 2 boxes, each containing either a white or black stone. So whenever and wherever a person opens one of the boxes, they immediately know the stone in the other box. This has been demonstrated across distances of hundreds of kilometers over time intervals of less than 100 nanoseconds. 1 nanosecond is equal to 1 billionth of a second. So, if the 2 entangled particles somehow exchange information, they do it at speeds at least thousands of times faster than light. But that's not all. Just like we stand on scales to measure our weight, scientists measure particles to discover their properties. But what if those properties only became determined the moment you measure them? This would mean our universe couldn't be both local and real. At least one, if not both, of these premises would be wrong. Defining reality is a tricky thing to do. We don't see tiny particles, yet they exist. We cannot touch the air, yet it is there. So what is real? In physics, real means that objects always have definite properties, regardless of whether we are measuring them or not. In other words, a falling tree in a forest makes a sound, even if there's nobody there to hear it. And local means that objects can only be influenced by their surroundings, and that this influence cannot travel faster than light. It's important that our world is real because, as Isaac Newton believed, if you know the positions and velocities of all ingredients of our world, and you identify the forces that influence them, physics can predict what the world would be at any time in the future. But the quantum world often has indeterminate nature. Put simply, it's often random or cannot be predicted. Consider a simple experiment. Fill a container with several radioactive atoms and wait. Generally, it can be predicted how many atoms will remain and how many will decay. However, you can never know for sure which atoms will and won't survive. Or fire a number of particles through a narrowly spaced double slit. You can predict what interference pattern will appear on the screen behind the slit, but you'll never know where every individual particle will land, even if they are being fired one at a time. Some aspects of quantum physics appear to be completely random. But are they really random? What if we just lack information? Albert Einstein believed that entanglement wasn't violating local realism, but rather that quantum physics was incomplete. He thought that the variables connecting these entangled particles would eventually be found. And the three scientists, John Clauser, Alan Aspect, and Anton Zeilinger, shared a Nobel Prize for proving these hidden variables don't exist. The scientists have reached a conclusion that an entangled particle doesn't have any properties until somebody measures it, and so these properties cannot be known or guessed by any means. So if the universe isn't real, then exactly what are we seeing and experiencing? A group of physicists in Los Angeles have come up with a new theory of reality, and it's based on periodic patterns or crystals. Crystals can be of different shapes, but also of different dimensions. Even more so, a higher dimensional crystal can be projected to create a pattern in a lower dimension. The resulting pattern is called a quasi-crystal. Physicists took a specific 8D crystal, projected it to 4D at a certain angle. From it, they have driven a 3D quasi-crystal, which they believe is a substructure of all reality. The fundamental building block of this 3D quasi-crystal is called a tetrahedron, or a three-dimensional triangle with all its sides of the same length. And this length is the smallest theorized unit of length in existence, called the Planck length, which is 10 to the minus 20 times the size of a proton. If an atom was the size of the Earth, a Planck length would be about the size of a proton. This is where it gets spooky. According to their theory, just like digital displays consist of the smallest units of a digital image, pixels, a tetrahedron is a 3D pixel of our reality. Each tetrahedron has just a few states in which it can exist, and a state of one tetrahedron defines the state of other tetrahedrons that fill the entire space of the universe. But if a tetrahedron can only be in one specific state in a given moment, who or what dictates the state it should be in? Physicists all across the globe believe that reality is made of information. But what is information? Information is meaning expressed through symbols, but meaning is nothing else but comparison or an ability to perceive something relative to something else. And if so, comparison and meaning require choice. In other words, consciousness. So just like when we know what the properties of an entangled particle are when we measure them, meaning or information can only exist when it's perceived or measured. If all of this is true, reality could be a product of consciousness. But there's also another idea for our existence. The simulation hypothesis, suggested by the Oxford philosopher Nick Bostrom. And some scientists believe the odds we live in a simulated reality are 50-50. So, if we were somehow able to prove we're living in a simulation, how would we do it? We'd have to start with the idea that the hardware which created the simulation doesn't have infinite computing power, because otherwise it wouldn't be possible to distinguish our reality from a virtually created one. Put differently, we wouldn't be able to notice any glitches. So scientists are looking for ways to make a simulation reveal itself with experiments that would create an overload on a theoretical computer with finite computing resources. Meanwhile, other scientists are finding other proofs. All computing hardware leaves an artifact of its existence inside the simulated reality it is running. So there should be a limit to the processing speed of operation per certain amount of time. And it happens that we have such an artifact in our universe, the speed of light, which remains the same regardless of the observer. It has an upper limit, and it cannot be explained by physics. So we may not know what kind of a computer is running our simulated reality or what properties it has, but there's one thing we can say for sure. If it performed one operation per second, its memory container size for the variable space would be roughly 300,000 kilometers. Perhaps we have this light speed limit because otherwise we would be able to travel to another galaxy before this computer could program it. But it's not the only indication we might be living inside a simulation. Movies or video games often go into the point of view of characters to demonstrate things from their perspective. What we see on the screen and hear from the speakers is the integrated experience that serves no purpose for characters. It's there purely for our benefit. And so if we accept the simulation hypothesis as our new reality, consciousness obtains a clear purpose. It's an integrated subjective interface that consists of 5 senses. No natural laws, philosophical or scientific ideas predict the emergence of consciousness, and there's no clear utility or evolutionary advantage that it could provide. So it seems its primary function is for there to be an experience. But since experience without any clear utility or evolutionary advantage is so energy expensive, it must serve someone else, an observer or a player. If one day we discover a way to simulate conscious beings, the chances we're living in a simulated reality would skyrocket. Physicists at the University of Maryland have already been able to simulate a single nucleus of helium that is composed of 2 protons and 2 neutrons. And they think that if they manage to simulate an atomic nucleus today, perhaps in 20 or 30 years, they would simulate a molecule, and in 50 years, an object the size of a few inches. If the progress continues, it's possible that 100 years from now, scientists could simulate the human brain. The thing is that if we are really living in a simulation, we aren't programmed to do things because we have free will. Perhaps someone wanted to see what we would do without any instructions, and what would happen. Perhaps the long years we experience in our reality would only be minutes to the creator of the simulation that we're in. However, to give a game character its own consciousness is something far beyond any technology that we currently possess. So what do you believe? Is the universe and everything not what it seems? Are we living in a simulation? We want to hear what you think. So sound off in the comments, and thanks for watching.